Hey there, folks. Hey, welcome back to another part of my thing, part 9, where we are making a Tetris data extractor to extract all the information from a Tetris ending screen, or even the playing screen, so we can turn the information on the screen into actual real numbers that we can deal with. We can sort them, we can save them, we can determine certain kinds of statistics that the game otherwise would not track. So last time, if you'll recall, we did this great win. We actually were able to correctly recognize digits based on the canonical digits. And some of you might be thinking, well, that wasn't so great since the test images we used that's how we build our canonical images, so they better match. But it was still a win because we ran through our algorithm. We matched them based on the algorithm, not based on the fact that they both came from the same image. So there might still be some bugs in our algorithm. I don't know. But those will show themselves as we continue. So today, if you recall last time, I had some issues with Visual Studio Code, and I thought I was going to be able to fix it, but you know what, I wasn't. So we're just going to run Windows. I installed a Windows 7 in VirtualBox because I don't need the Windows for anything except for running Visual Studio. And in Visual Studio, we can publish these packages to run on any operating system, so we're fine. We can develop on Windows and run on Linux. Not the best, most efficient way, but that's okay. And oh look, Windows 7 is updating. Windows 7 is no longer used. It's no longer receiving new features or anything really. But anyway, here we go. Let's do this. So this will be more or less like our earlier videos. And I'm trying something new with the headphones here. I've had some real audio issues. I'm actually now recording audio from different sources, and I'm just going to pick the best one and see what happens. All right. So we a few things we're going to do today. So I want to clean up some of the code. We've got some extra code in here that we're not using. I want to rename some things and possibly look at our algorithm. We'll just look at our algorithm really quick to see if there's any easy wins we can do for simplifying it, but I don't think there will be. So the first thing I want to do is I want to clean this up. So remember, we had digit reader 2. This is what we were working on. This is our algorithm to recognize a digit. That was called digit reader 2 because we tried this other one first, which didn't exactly work out. 1 second here. I got my audio cables mixed up here. Okay. There we go. That in there. I just put it there. I did like that. Okay, we'll see. We'll see how that works. So suffice it to say, this fingerprinting with the black pixels didn't work, so I want to delete it. We're just going to delete it, and it will be permanently deleted, and that's okay. Digit reader 2 now can become digit reader. Oh, but we also had some digit reader tests, which we don't need anymore either. We'll delete that, clean things up. Right on. So digit reader 2 is now the only digit reader in existence. So we're going to go ahead and rename this file to just digit reader. And yes, I'd like to rename the class as well. Perfect. So everywhere we had digit reader 2 is now called digit reader. So I should rename the tests. Yes, I would. Digit recognition. Okay, let's just run through these quick tests just to make sure I didn't ruin anything. Let's run through all the digits, make sure we can still recognize each of the 10 digits. And we can, so that's good. And you'll notice they run on the order of milliseconds. It's very curious why recognizing, what is this? The digit 6. Oh no, 7 took the least amount of time. And the most amount of time was 1. I wonder if that would be consistent if I ran it again. This time it was 6. Still 0 and 1 seem to be taking an awful long time. The problem is speed. I'd like to be able to do this in real time, not just with an image eventually. And so a real-time video feed, this is going to have to be as efficient as possible. But we talked the last time about like bailing out if we can detect that the 0 is in fact the 0. It's the first one we try. Yeah. Okay, whatever. That's fine. Excuse me, that works. And we have our model that we built on the first one, the first part of these videos. That's fine. Digit reader gets digit. Oh yes, this is one thing I want to do. So inside digit reader, we have this. Oh boy, lots of methods. We have this method called reduce image. And if you recall, that took an image and eliminated all the black border around it. So we shrunk the image until the non-black pixels were touching the outer edge. And I think that's something that we're going to want to actually do more than once, and more than just inside the digit reader. So what I'm going to do is I'm going to actually make a digit reducer or an image reducer, and I think we'll make that into a new folder. So I'm going to image manipulators, and we are going to add a new interface. And this will be called image reducer. Okay, it could be internal. You know, I kind of like making things public. I know that's bad practice, but actually if you make them public you can test them, and there are ways to get around, so you can test internal classes, but for now I don't really care. This interface, this is going to have a public now is this a void or is it going to return the bitmap itself? Let's go back to our digit reader, see what we did. So we are actually returning the bitmap, and we're taking a bitmap because we're cloning the original image. Yeah. So, okay, that's fine. We're cloning the original image, so we will have to return a bitmap. Reduce image. And we'll take in a bitmap, and we will return a new bitmap with it being reduced. Okay, so now that we've done that, we'll add our class image reducer. This will extend the interface image reducer. Visual Studio will say, if you're an image reducer, you're definitely going to need that method. So there we go. Now I'm just going to grab the code from here. Let's just copy that. Throw it there. That's it. That's all we. Oh, we need these methods too. Well, that's good. We'll clean up the digit reader a bit. Yeah, so we're gonna need these. Go into our image reducer. Okay. We need to use the link. Good. Oh, we need the is black pixel. Okay. So in the digit reader, the only two cases where we're using this method is in reduce image. So right now, all of these we don't need anymore. But the is black is actually used elsewhere. So what we're going to do is we're just going to copy the is black and keep it in both places. It's such a small method. It's going to be okay. I promise. Okay, so that's done. Now there's going to be things here that we don't like because now we can no longer reduce the image. But that's okay. Now we need to bring in an instance of the image reducer. And digit reader is now going to require image reducer. Okay. There we go. So now when we ask for a digit reader, we need to supply an image reducer. And then we will why isn't that showing up yellow? Okay, whatever. Okay, good. So now that we've done that, now we've moved our image reducing algorithm into its own file. And that's good. Let's clean that up a bit. Good. All right, folks. That is moving that. Now, what else in here can we get rid of? Not necessarily get rid of, but fix up. The same size and the same height and the same width are almost identical. It's just we're using height. But you know what? I don't think it's worth it to get fancy and combine the two because they're just ever so subtly different from one another, that it's not going to be, yeah, whatever. I think we're fine here. Okay, so we've done that. Now we have this. Actually, what I'm going to do, hold on one second. Open up Git Bash here. Here, clean up in part 9. So, every time I install a new operating system, I had to do this last time too, but that's because I was in Linux. Whoops. One day, Git won't require an email address when we stop using email addresses. Because we will stop using email addresses, I promise you, some point in time. Okay. Now I can commit my stuff again. kicks. All right, good. So now we've actually frozen in time our code as it stands right now. Good. Now the digit reader tests will not run because we're not providing an image reducer. So there we go. Let's give it an image reducer. Okay. And we can run the tests again just to make sure that we didn't break anything. And now what we're going to... What? Build failed. Oh, come on. Ah, the screen reader. Okay, so this is, yeah. Okay, we're going to move away from tests now. We're actually going to build up our actual classes. So this is our screen reader, and this is exactly what I wanted to get to today, is dealing with our screen reader. And if you remember from many parts ago, I don't even know which one, the screen reader's job, I don't even have it as an interface. Wow. Okay. The screen reader's job, we had this get value at where we, given a screenshot, an image, we can say at this XY coordinate, get me a certain number of digits that I expect to see on screen. And this was going to be our way of reading entire numbers, like the score or the level you're on or the number of T-bars you've gotten or something like that. And this is the way we did it. Now we did this just so that we could test it and see it work, and it didn't work because our digit reader algorithm was incorrect. And that's what eventually caused us to do a different algorithm and call it digit reader 2. And anyway, whatever the case, now we're going back to screen reader, and now we're going to clean this up. The first thing we are going to need to do is to make this an interface. So I think I can right click this and I can extract interface. iScreenReader, new file name, iScreenReader, boom, done. So there it is. So there's our interface, which is nice. And there's our screen reader. Okay. So the X width and the Y height, or the height, the width and the height of our characters on the screenshot. Remember, this is a screenshot from an emulator, a Nintendo emulator. So it's crisp and clean, and it's 1080 pixels high. And I think we even have an example of this screenshot. Let's just open it up in Paint. Here it is. Here is the screenshot that we're actual. We'll shrink it a bit, but this is actual size. What? Okay, that's 50%. So yeah, we're gonna try and take all of these numbers and turn them into something. And I don't care about the top. I never did. It's certainly something we can add. Drawing the box. It's certainly something we can add into the algorithm if we want to, but that's all right. So in this example, each character is 45 pixels wide and 39 pixels high. And that's what prompted us to have these constant values here. All right. The next thing I want to do is I no longer want to supply a bitmap to this screen reader. Because for those of you who understand the concept of dependency injection and its closely related cousin, inversion of control, that's what I want to use. And I'm most familiar with autofact, so that's what I'll be using. And I don't really want to supply things myself. So instead of supplying a bitmap to the constructor, we're going to be supplying it here. Into the get value at. And we're just going to get rid of these underscores. So that's what's happening there. And then the screen reader needs a digit reader. But I also think it needs a reducer. Now the digit reader also needs a reducer. But, well, let's bring in the reducer when we want to. Because my thought is, if I give it like a funky screenshot, we first want to reduce the screenshot itself. But let's deal with this nice case where the emulator is giving us our screenshot. Okay, screen reader, this interface now needs a bitmap. Needs to take in a bitmap. We need to tell it what a bitmap is. Okay, good. All right, so now we have the digit reader. And we're getting the value. How did we do that? New. Oh, I'm running out of disk space on drive C. How, holy crap. 108 megs free. That is a problem. Well, let's delete all these things I downloaded. Before our next part, I will have to increase my hard drive space. Okay, 1 second, folks, while I empty my recycle bin. Okay, how much room do I have now? 217. Woo! It's because I only made the size of the virtual hard drive 32 gigs, and then I installed Windows. Okay. So that's fine. So we crop the area at x, y, digits times x width and y. So we create a rectangle the size of the number of digits. And then we get that sub-image as a screenshot. And then we go through each of the columns in that screenshot. So now it's just a little sub part of the screenshot where each, it's just going to totally encase the number we want. So that makes sense. Then we get the image that we think is a single image, and then we pass that into our digit reader, where we'll have a final number is our digit. We concatenate the digits because they're coming back as strings, and then we parse the final thing as an integer, and we return that. This should be fine. So this is our algorithm for getting a number based on the fact that we've already solved getting a digit. So we don't have to worry about how to get a digit at this level. We assume we can properly get the digit. And this is the algorithm we're using. Now, the way to test this and to run through this is probably just a test. I wanted to move away from tests, but I'm too excited. I want to see this work now, and I don't want to add in all the autofact stuff right now. So let's go to our screen reader tests, which we already wrote last time. One second, folks. I'll be right back. Okay, that will be edited in post. Okay, so we've got our test that we wrote long ago, discovered it didn't work. So then we went back and did a whole bunch of test sessions on revamping our digit reader algorithm. So now we're back to our screen reader test. And we're just going to get the screenshot. And SUT is going to be a new screen reader. And I need a new digit reader, which needs a new image reducer. This is not the way you write unit tests, by the way. This is the way lazy people. Essentially, I'm using the test to just see the code execute. I could have written a main function and did all the things, which we'll eventually do. I just want to see this work. Okay, and now we have to pass in the image. All right. So let's open our screenshot. And I am asking for something 1143,769. You know, let's open our screenshot up in Paint. So 1143,769. Where is that? Should have a pixel count in the. So 11. Huh. 1143. Oh, this is. Okay, so I'm trying to look at this level, the 1. I don't have the select box. I'm looking at this 1, and I want to see it register itself as a 1. And that's why the X value, Y value, and then I only have the 1. This is a give me the just 1 digit in this position, and my score now should be 1. Now, let's rename this to value because it's not my score. Okay, let's just see that this works. I'm just going to run it. I'm not even going to debug it. Just let's run it and see it. Oh, guys, wow. Now, if I get the 2 digits at that location, I want to see the value 16. And you might not be able to see it on your screen. Maybe I should be increasing this a bit more. I'm looking at this green check mark. I'll go into the Test Explorer, and we could see these tests here. Okay, let's try it. Oh, let's debug it. I mean, I already got the green check mark, so I know it works. There's just something satisfying to see the value be 16. Oh, folks, we just read the value 16 from a screenshot. Okay, let's get the score. So I'm going to start at pixel 1050 268. Well, let's draw a 45. Yeah, so if I started the beginning of this box, 1054 269. Let's do it. So 1054 and then 269. And now I want 6 digits worth. And my value should be 195,640. I'm going to debug this. It's too epic to just rip the Band-Aid off all at the same time. I want to see this step by step. Well, sort of step by step. What is value? Oh, guys. Oh, my word. Well, that's our hard work paying off. Okay, so the screen reader itself, I don't really care about. That's not. Screen reader. So I have a digit reader. I have a screen reader. What's a better name for screen reader? Because I want to. No, that's okay. We'll call this a screen reader. So what this is going to do, the screen reader does this, okay? Any bitmap takes an XY value and a number of digits and returns the digits. That's all it does. That's not as fancy, or it's not as efficient for us to use in the context of a Tetris screen. So we're going to make a helper class called a Data Extractor. And we're going to put this into a new folder. Whoops. Data extraction. Okay, so in data extraction, now we're going to have this interface called Data Extractor. And this is going to give us, this is where we will use the screen reader to get at the data that we want. So I foresee two instances. One, I want to read the entire screen. I want to read the entire screen and get back all possible information. Maybe at the end of a game and I want to save all my statistics. I foresee another possibility where I'm actually actively monitoring a video feed of a game and I only care about the number of lines, for instance. so I can watch it, and if it goes up by 4, I know that I just got a Tetris. So if I'm only interested in the number of lines and I'm doing it in a video feed, I'm going to want to be able to do that as quickly as possible. So there's no point in me calculating and extracting all the data every time when all I care about is the number of lines. So I think our Data Extractor class is going to allow you to do both. So it will be able to give you a model, this model here. It'll be able to read the entire screen and get you one of these things back. But it will also be able to do each individual thing. Some of them aren't going to be nearly as important. In fact, actually, I cannot imagine. I think we'll want the number of lines and the number of long bars, perhaps. Anyway, let's build it. So let's say public a Tetris data model get all data, and this will be from a bitmap. Okay, I think I'm going to actually say get long bars from a bitmap. And get lines from a bitmap. You know what? Let's just do this. We'll just say get lines for now. That is the one I can see being the most important if you're just interested in one thing. So, okay, let's build one of these things. So we will add a new class called a Data Extractor. All right. Make it an instance of this interface. These are the things we need. And now we're going to need a screen reader. That's it. For now, that'll be it. So let's bring this into the constructor. Okay. We're still far away because this is all still with ideal screenshots, emulator screenshots. If you want to be good at Tetris, you have to play on a CRT monitor. And that means you have to use a real Nintendo. And that means your screenshots are going to be very fuzzy. They're not going to be as nice, crisp, and clean as what we get from an emulator. So it still remains to be seen if all of this is going to work nicely with real screenshots from a Nintendo. And there's things we're going to do to fix issues. But this is such a big step forward. It felt like we were spinning our wheels for so many weeks. Okay, get all data. All right. Okay, we're going to open up our Tetris data model and just see what we got here. So we need the score, the level, and the lines. Whoops. So private int score. Private int level. Private int lines. Oh, and I already seeded. We'll just get rid of this. No, we won't get rid of that. It'll actually be a different. Oh, that's fine. What am I doing? Getting the lines in the public sense will be different from getting the lines in a private sense, because I'm going to assume in these private methods that the bitmap has already been reduced. Getting the lines, I will not make that assumption. Okay, so we've got that. T, J, and Z. Why do I keep alt-tabbing? Okay, now I'm going to duplicate. Oops. What? I thought TJZ, O, I, something else and something else. Can't remember. But there are 7 of them. TJZ, O. T, J, Z, O, S, L, and I. S, L, and I. All right, so we've already figured out the score. The score is what we did in our tests. 1054, 269, and 6. Come on. Okay. Return screen reader. Get value at. Can't remember. 1054, 269, and 6. Okay. Now, if I undo a few things here in this test, we'll get the old values back. 1143, 769. The level. $1143, $769. The level. And we're going to get 2 of those levels. 2 of those digits, because the level is 2 digits. Okay, the number of lines is right here. Those pixels are 836, 72. $836 and 72. $836 and 72. And there's going to be 3 digits there, because 3 digits for the lines. Not sure what it does. I think it pre-pads everything with a 0, because it does with the top here. It does with the piece count here. So I'm assuming it will in the lines, I think. We're just going to assume that. And then if you have a 0 in front and of a string of digits, parsing the int, parsing it as a number, will toss away the pre-padded zeros. So okay, T number. Okay, so T, and all of these will be similar. I think what we're going to do is we're going to 259, 417. Let's just do that. The J, I don't know, 494. The Z, $574. Oh. Let's actually, let me just copy this. Oh, it's getting hot here. I think we're in for a heat wave. And I'm on a second floor without air conditioning. It's getting so hot. So the T, 259, 417, and it'll be 3 digits. The J is 259, 494, and it'll be 3 digits. Makes sense that all of these are the same X value. In fact, I'm just assuming. So the O, we'll just use 650. The S, use a value of 728. Sure. Okay, L, use a value of 806. And the I, ever important long bar count. Oh, folks, look at that. If I use 259, I might be hitting the long bar. Okay, you know what? New plan. Let's use the X coordinate of 261 and the long bar 883. Use 261 for the X coordinate of these things. I mean, the others don't really matter, but it's nice if they all sort of work out. Now, there are other things we can detect in the screen. I do want to detect if we're on the rocket screen. but that'll come later. Okay, so we have all these private variables. We can eliminate these comments now. Good, so let's collapse everything. Right now, our get lines is just going to be I think we're not going to care about reducing right now, so we're just going to return lines bitmap done. Okay. Because we're still using emulator screenshots, we don't have to reduce the actual bitmap. Okay, so this is where we're going to say return new Tetris data model. The level equals level bitmap. Lines equals lines bitmap. Oh yeah, you can see where we're going with this. Score equals score bitmap. And then we have all of these. And it's going to be in alphabetical order. So okay. I number bitmap. J number bitmap. L number bitmap. So it's nice how, you know, you sort of fake out the higher levels, get down to the nitty-gritty digit recognition. And then once you're done that, then you can revisit the higher levels after solving the digit problem. And honestly, I was a bit scared that this wasn't going to work. And we're still not in the clear yet, but if this didn't even work with the emulator screenshots, I didn't have another idea. But okay, so there's getting all the data. We're just getting everything and returning the Tetris data model. And the screen reader is going to use the same bitmap because we're just passing the bitmap. We're not copying the bitmap except until here, where we're creating a crop point. Okay, so now that we have, why doesn't control, weird. Now that we have our screen reader, let's add a new folder for data extraction. Data extractor tests. Okay. So, here we go. Are we excited? I'm excited. I'm super excited. I'm going to create a private class variable. Nah, I just have one test. Public. Get, what did I call it? Get all data. Get all data. Should get all data. Okay, we're going to use the same test image. Maybe I'll copy it into this one just because it's not necessarily the same here. I should oh, already set to copy. Okay. So we're going to copy the screen reader test by just doing this. Instead of screen recognition, this is data extraction. Okay. All right, folks, here we go. The system under tests is a new data extractor, which requires a new screen reader, which requires a new digit reader, which requires a new image reducer. Okay. A lot of classes there, but that's okay. Because of inversion of control, this gets simplified when you actually run the thing. And if we were actually writing correct unit tests, we wouldn't need to pass in anything. What we would do is we'd create a fake screen reader and we just dump it. But again, these tests are just a way for me to see this work. So, okay, let's var result equals get all data from the image. Here we go, folks. Now we have to set this up. I'm going to move. Oh, that's right. I only have one monitor right now. Yeesh. Okay. So result dot lines should be, I think it was 106, 103. Should be 103. Okay. Result dot score come on, should be 195,640. Result dot level should be 16. And then I think we're just got these here. So not toString, T number should be 41. J number should be 42. Result dot O should be 37. Not sure why I skipped Z. 39. Okay. Result dot S number should be 31. And the L number should be 31. Yeah, that S should be 45. Okay, last one. The long bars should be 51. Wow, that was a pretty nice game. Getting lots of long bars in a game is nice. Okay, this is a test. Will we correctly do this? And if one of these is wrong, it'll throw an exception and we'll see which one is wrong. So let's just, I have to make this a test. And my phone is dying, so we will, hopefully this will work. Okay, let's go to the Test Explorer. The data extractor tests. Let's do it. This is super exciting. Come on. Come on. Wow. It took 2.6 seconds to figure it all out. See, and if I change this, like if this one was 44, let me just show you guys that this would conk out. See, it says no, you know what, if you go down here, you know, expected S to be 44, but we found 45. The test expected 44, but it found 45. Wow, it works. Okay, this is a perfect place to end this. The next thing I need to do is to start focusing on, oh, actually, before we leave, let's make another test, because we just had the number of long bars, right? Or not the number of long bars. Get lines, should get lines. I'm curious to see how fast this one runs. Get lines from the image. Now we know it's going to pass, so that's not too bad, but I want to see how fast it runs, because maybe I want to do this every second. So it takes 0.3 seconds to figure out how many lines a screenshot has, folks. So while I'm actually playing a game, accepting a video feed, I could even be extremely conservative and take screenshots once a second, and I'll be able to get the number of lines in that screenshot in less than 0.3 seconds. So that's fantastic. Okay, anyway, we're gonna leave it here. Next time we are going to have to put the algorithm to the real test against an actual Nintendo screenshot, and we'll see what happens. Okay, thanks for joining me. We'll see you next time.